There's really just one rule for structural and geotechnical engineers designing foundations. When you put something on the ground, it should not move. That seems like a pretty straightforward directive. You can put a lot of stuff on the ground and have it stay there. For example, several years ago I optimistically stacked these pavers behind my shed with the false hope that I would use them in a landscaping project someday, but their most likely future is to sit here in this shady purgatory for all of eternity. Unfortunately, buildings and other structures are a little different. Mainly, they're large enough that one part could move relative to the other parts, a phenomenon we call differential movement. When you move one piece of anything relative to the rest of it, you introduce stress. And if the stress is greater than the inherent strength of the thing, that thing will pull itself apart. It happens all the time, all around the world, including right here in my own house. When one of these piers settles or heaves more than the others, all the stuff it supports tries to move too. But door frames, drywall, and ceramic tile work much better and last much longer when the surrounding structure stays put. Of course, buildings are heavy, and one of the most important jobs of a foundation is to evenly distribute that weight into the subsurface as downward pressure. Soil isn't infinitely strong against vertical loads. It can fail just like any other component of a structural system. When the forces are high enough to shear through soil particles, we call it a bearing failure. The soil directly below the load is forced downward, pushing the rest of the soil to either side, eventually bulging up around the edges. Even if the subsurface doesn't full-on shear, it can still settle. This happens when the particles are compressed more closely together, and it usually takes place over a longer period of time. Job number one of a foundation is to distribute the downward force of a structure over a large enough area to reduce the bearing pressure and avoid shear failures or excessive settlement. Structural loads don't just come from gravity. Wind can exert tremendous and rapidly fluctuating pressure on a large structure, pushing it horizontally and even creating uplift like the wing of an airplane. Earthquakes also create loads on structures, shifting and shaking them with very little warning. Just like the normal weight of a structure, these loads must also be resisted by a foundation to prevent it from lifting or sliding along the ground. That's job number two.